So we're working on percent composition. What that means is what percentage of the compound is one element, what percentage of the compound is another element. And when we say percentage, it's usually by mass. So if we look at a formula like H2O, we can tell that 2/3 of it by number of particles, 2/3 of it is hydrogen and 1/3 of it is oxygen. But by mass, it's different because hydrogen's mass is 1.01 and oxygen's mass is 16. So by mass, the ratio comes out differently. So let's take a look at this. So percent composition is what percent of each element is in a compound. So it's going to tell you like of H2O, what percentage of it by mass is the hydrogen, what percent is the oxygen type thing. And this will um, add right on to molar mass. So this is the part where I was telling you make sure you show me the totals for each element because we're going to use those. Okay, go on to the next. Okay, so this is how you're going to find it. You're going to do a molar mass, just like I showed you, where you figure out, like if in the example with water, 2 times the molar mass, the hydrogen, which is 1.01, so that'd be 2.02, and then 1 oxygen times 16 would be 16, then add it together. That's the molar mass. Then you're going to take each of the elements' totals divided by that molar mass you calculated times 100, and that will give you the molar mass of the compound, or the molar mass, I'm sorry, the percent by mass of each element in the compound. Make sure you round it to the hundredths place, 2 decimal places. Stay out of scientific for this because it's hard to tell where the hundredths place is with that. And then the label is just percent. So it's that easy, and I usually just take my molar mass, fill it out, and then add an extra column and put the percent sign at the top of that column, and then I put my numbers in, and I don't have to write percent on each one. So let's take a look at an example. So our example is going to be SrCl2. So we're going to do a molar mass first. So we're going to list them out separate. Sr, the R goes with the S because it's lowercase, so we know it goes with the S. And then Cl, and I know you can't, sometimes some people have trouble telling whether it's Cl or Ci. All I can tell you is if it comes after a capital C, assume it's an L, a lowercase l. So 1 Sr, 2 Cls, and then times the molar mass from the periodic table, add it up. So I got for SR, I got 87.62, and then 2 CLs times 35.45 gives me 70.90. I add that together, I get 158.52. Then for each one, you'll have an answer for each element. For each one, you're going to take that total for the element divided by the total for the whole compound times 100. So for SR, it's going to be 87.62 divided by 158.52, and then times 100, and then round to the hundredths place. So 55.27. And then for CL, you're going to take the 70.90, not the 35.45, the total. 70.90 divided by the same number, the total for the whole compound, 158.52, times 100, round to the hundredths place. Now I did those below in blue because I wanted you to see how I got the numbers. But when I show my work for this, I don't show the blue part. I just put a whole nother column up beside my molar mass called, I title it percent at the top, because if you put the percent sign at the top, you don't have to put it on every single one. So I put a percent sign at the top, and then I put in my numbers that I got for each element. And that's all I show. So it's just a little bit more than the molar mass. Now, if you want to show the blue part, you can. You have to show the black and the red part. But that's how you do a molar mass. I'm sorry, percent composition. It's also how you do a molar mass with one more step. Okay, so we're going to try another one. You guys are going to actually do this on paper. You can do it in your notes. Going to have scrap paper, but you need to do it. So write down Al2 parentheses CO3 parentheses 3. Find the molar mass of that. List each element out separate, Al, C, and O, and then how many you have of each one. Then take that number times the molar mass from the periodic table. That's your total for your element. And then add it all up. It should look something like that. Then take each one of the totals, so the 53.96, 36.03, and the 144, each separately, divide those by the total for the whole compound, the 233.99, times 100. Then round to the hundredths place. So 53.96 divided by 233.99 times 100, rounded to the hundredths place, I got 23.06. Then take 36.03 divided by 233.99 times 100, I got 15.40. Then take 144.00, I guess, divided by 233.99 times 100, and I got 61.54. Now, conveniently, they add up to 100%. I think both those examples did, but sometimes it won't because we're going to the hundredths place. But it should come out really super close. So, just so you know, go with the hundredths place no matter what, even if it doesn't add up to exactly 100.